Welcome back, everyone. Thanks for tuning in. We're going to jump right in here. Thank you for all those who are actively participating in some of these Google Forms and these videos each week. I always appreciate that, and thank you for those who are sending me emails about updating your grade and whatnot. It's nice to see that. Remember, I think I sent out an email earlier this week. All late assignments and missing work and redo assignments, they're all due by next Wednesday, so that's next week's Wednesday. I don't know the date. I think it's the 20th maybe. So I'm going to send another email for those who are, trying to boost their grades up a little bit. But again, let's jump right into the iPad and let's talk about the subjects this week. We're in week 8, part 3. So, all right. So what you're looking at here is my iPad. Obviously, we've been doing arc measure from this past Sunday's video and obviously Tuesday's video where I sent out some links to some other websites that you can check out. But we're dealing with circles, or the idea of adding angles up to make a full polygon. Now, a circle is not a polygon, it's a conic section, it's a part of a cone. But we can use the same kind of ideas from a circle to other objects. And you'll see that in some of these. Now we're going to go over the Google form answers. I think there was 10 problems that we had. I'm going to jump right in and kind of work our way through them. I might pull up a calculator every now and then. But yeah, let's jump right in. Let's kind of see how we're going. So the first problem here. So what you're looking at here is a circle, and they want to know how many angles are acute here. Now, obviously, currently, acute means anything from 0 to less than 90. So right now, there's already, actually, I grabbed that. There's one angle that's acute currently. Now, we do have to find the missing angle. We have to find this mystery angle over here. So what we need to know, and this is part of that, the subjects that I sent out last week or Sunday, I should say, circles have to add up to be 360. So a full circle is 360 degrees. Again, we talked about, what the Byzantine Empire was based on the calendar. 360 days go around the sun. And so we've used that, even though they weren't correct, but they're really close on their math. But we still use that fact for circles. It's kind of a weird history that we still use it. So we need to find this mystery angle. So what we're going to do is we're going to take 360 and subtract these 3 angles off of it. And we're going to get to that number. Now I'm going to just pull up my calculator here just so you can see it. So what you should be looking at here is my calculator screen. Let's type this in. So we're going to type in the 360 first, and now I'm going to subtract the 3 angles. I'm going to subtract the 62, subtract the 90, and subtract the 117. And what's left is this final angle, which is 91 degrees. Now again, so 91 degrees, let's transfer back. So that final angle ended up being obtuse. So on this one, there's 2 angles that are obtuse. They're bigger than 90. There's one that's a right angle, exactly 90, and there's one that's acute. So to answer the question, how many angles are acute on this picture, there's only one, the original 62. That's a lot of work, I know, but just understanding this problem will help us with the next ones. So let's kind of jump onto the next one. So we're on problem number 2 here. What is the size of one angle at the center of a regular pentagon? So it's a 5-sided polygon. So if I draw a 5-sided object that is supposed to be regular. Now, again, if you don't know what regular means, it's a specific word in geometry. I know it seems kind of odd, but it means every wall is the same and every angle in the corner is the same. Now, they want to know the angle at the center. So if you were to draw, maybe this isn't, I'll use a different color here. Let's go like a light blue. If I were to draw things like this, okay, and make it at the center. So let's say this was the perfect center of that object. We could find each angle. These angles would have to be the same if it was regular. That's just something that you need to know. And so we can find that because all those angles have to add up to be 360. It's a full circle on the inside, like right here. Not the actual pentagon itself. Like we've talked about how to find angles in a pentagon. We're talking about the center angles, the central angles. That was the whole point of this week's video. So there is 5 angles there at the center. So if we add up all 5 angles and we just call them the same, there's 5 x's there. X, 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 X. They're all supposed to be the same mystery angle. There's 5 x's, and that should equal 360. All you have to do is take 360 and divide by 5. So I'm going to do that now. So you can see my calculator. 360 divided by 5. There's 5 mystery angles there. and they should all be 72s. Each x should be 72 degrees at the center. Now that's the center, that is not interior angles. There's a difference there in vocab terms that I want you to kind of understand. That interior angles are, if you had your Pentagon, interior angles are the angles like right here. Like they actually touch the vertices, that touch the corners of the picture. We're talking about the central angles, ones at the center and that make a circle at the middle. So those are all 72s. Okay, now this one's talking about a ratio. There's 3 angles in this picture. They're all mystery angles. One is a 1x. The other one is a 4x because they're in proportions to each other. And the other one is a 7x. So if you knew what the first angle was, number 1, that, let's say it's 50 degrees. I don't know what it is. Let's say it's 50. The next angle would be 4 times that. And then the third angle would be 7 times that. They're all related to each other. It's a ratio. So that means one just scales to the others. We want to find the middle of the 3. So the middle of the 3 is the 4x. So we want to find this one, right? So what we're going to do is we're going to just add up these angles because it's a center, right? These angles are all based on a circle. So the 1x plus 4x plus 7x should equal 360. So if I add these up, that makes 12 x's total. And so I'm going to take 360 and divide by 12. And I think it should be 30, but transfer to my calculator here. So 360, and we're going to divide by 12. 30. So x is equal to a 30. Now, that is just what x is. What we need to do is we need to figure out what the original angle should have been. So we got to plug this 30 in, and we want to find the middle angle, the size of the middle one. So we need to plug the 30 in here. So 4x is the middle angle. I want to plug in the 30 here. 30 times 4, that's 120 degrees, and that's the angle that they're looking for on this. What is this, the third problem? Okay, let's go to the next one here. So we have 6 angles at a point. So it's, let me just draw this like that. 6 angles. Okay, there's my 6. And one of them is 45, so let's just call this one 45 degrees. And all the other 5 are equal. Okay, so let's just call these all x's. We don't know what they are. They didn't tell us what they are. They're just all the same, those 5 angles. What are the size of each of those angles that are equal? Okay, so these should all add up to be, there's 5 x's and that 45, and these should all add up to be 360. So, first step, if you're solving this like Algebra 1, you have to always add and subtract first. Now, some people, I'm always mystified by this. Some people have never heard the little acronym SADMEP. It's PEMDAS backwards, but this little acronym is how we solve equations, something that has an equal sign. You have to add and subtract first, so I need to get rid of any adding and subtracting numbers. So I need to subtract the 45. And again, why you do this, you always do inverse operations. This is literally the inverse of PEMDAS. It's the flip of it. So we always have to do inverse operations, so you do opposites. So to get rid of the 45, so you subtract it. And what is that, 315? I did that right. Let me bring it here because you guys know I can't subtract my head. So 360, subtract 45. So I get 315, and then I'm going to divide by the 5 here. So the last step here is to divide by 5, divide by 5, divide by 5. So 315 divided by 5, and I get 63. And there's your angles. That's all those mystery x's. Okay. Now, let's go to our next one. So, next angle, we want to find angle C. So it's kind of like before. We have a bunch of angles here. We're going to add these all up. Let's see, 79. And this should make 360 again because it is a full circle. So if I add these up, and I'm going to subtract them from 360 here. So let's jump right calculator here. We're going to take 360, and we're going to subtract each of these angles. We're going to subtract the 70. We're going to subtract the 63. We're going to subtract the 45. We're going to subtract the 79 to the other side. And if we do this right, we're left with C should be 103 degrees. So there's your mystery angle. And it kind of looks like that. This angle looks obtuse. It looks bigger than 90. Not by much, but the human eye can kind of pick that out. Okay, let's go to question number 6, I think. Let me jump right back to my screen so you guys can see me. All right, I know you don't want to, but there you go. So the size of one angle at the center of a regular nonagon. So a nonagon is a 9-sided polygon. It actually says it there. So a nonagon. So this is the angles at the center. So if you think about this, and I keep drawing it, there should be 9 angles in there. These call these all x's, and it is regular, so it means they're all the same. Now that seems really odd. That word regular in geometry is very specific. Every angle's the same. Every wall's the same. It's quite unique, actually, as opposed to what the word actually means in English. But there's 9 x's, and they should all have to be 360 at the center, because this should make a total of 360 for the circle. So I'm going to take 360 and divide by 9, and I believe we should get 40, but let me just double check on a calculator. 360 and divide by 9. Yeah, should get 40. Alright, and that should be each of those angles at the center. So, okay, so let's go to the next one. We only have a few problems left here. Alright, so we have 4 angles that come to a point, so we make a circle in the center, as you can see. They have the ratios of 3, 4, 5, and 6. So, let's call this 3x, and let's call this one 4x, and 5x, and then 6x. So they're all based on what x is, so they're all multiples of each other, there's ratio. We want to find the smallest angle of the 4, so that's probably this angle right here. The 3x should be the smallest angle. But we have to add these all up, and they should add it to be 360, because it makes a full circle in the center. Okay, so what do we have here? We have, what, 15 x's? No, 18 x's. Sorry. 18 x's. 18 x's. We're going to divide. I believe this should give us 20, but if I did the math right in my head, let's just refer to the calculator. Here's 360. Divide by 18. Yeah, 20. Okay, so good. Okay, now let's jump right back. Okay, so now the smallest of the 3, we have to take this 20 and plug it back in. Now the smallest angle is the 3x, so we have to take that 3x and plug in the 20 here. So that's 3 times the 20, which is 60 degrees, and that's the smallest angle out of the 4 that we were given. Okay, let's jump to the next one here. Okay, so we only got, I think, 3 problems left. Alright, so we have a bunch of x's. They all meet at a point. So we have x, a 2x, 3x, 4x, and a 5x. And what is the largest angle of these? So that would be the 5x, right? That's the largest, but we have to figure out what its value is. So we're going to add these all up. 3x plus 4x plus 5x. And that should equal 360, makes a full circle. Now the x in the front is a 1x, so just so you know that, I'd put the 1 there. If they don't have it printed, it's always assumed it's a 1. It's one of those math facts. Alright, so adding these up, well, we have 15 x's, I think, on this one. 2 plus 3 plus 4 plus 5 plus 1, that's 15 x's. Alright, and that makes 360. If we're going to divide by 15, I don't know if this works out to be a nice clean number. It might. Okay, so 360, let's transfer the calculator here. Alright, so 360, we're going to divide by 15. 24, it actually did work out to be a nice pretty number. 24 degrees, that's kind of nice. Doesn't happen too often. Alright, so 24 degrees, now we have to find the largest angle here. So we have to take the 24 and plug it back in. So 5 times the 24. Now if I did this right in my head, should be 120 degrees if I did that right. That would be the largest angle, 5 times 24. Okay, let's jump to the next one. We have 2 problems left. Okay, so we have 5 angles here. AOB. AOB is this one. Now, how I know that? 3-letter acronym, A to O to B, so that's the 71. BOC is this angle right here. COD is this mystery angle. I don't know what that one is. It looks kind of like 90, but we'll figure that out here in a minute. A DOE, that is that angle. And an EOA, that is this angle. And it wants to know how many of them are obtuse. That means bigger than 90. Okay, so let me erase all these marks. So, currently, I'm thinking these two, the ones I have currently marked. Now, I do need to figure out that mystery angle. EOA for sure is obtuse. That's the 91. I don't know about this, what, COD? This one could be a mystery. The other 3 are acute. these are all smaller than 90, so those don't count. But I do need to figure out the mystery ones. So x plus the 43 plus the 71 plus the 91 plus the 62 should make 360. Okay, so I need to subtract those over. I'm going to jump right calculator here. Let's take 360. Let's get rid of all those angles. So let's get rid of the 43 first. Let's get rid of the 71. Let's get rid of the 91. Let's get rid of the 62. I'm left with 93 degrees. So this mystery angle is 93 degrees. So yeah, for sure these are obtuse. It kind of looked like it. It looked like 90, but we had to make sure it was obtuse because obtuse means bigger than 90, so I had to make sure of that. So there you go. There's the 2. There's 2 of them. Let's jump right back in. Okay, so let's go to my last problem here. All right, so find angle C. So we have to find it for the mystery center. So C plus 36 plus 95 plus 101 plus 44 should make 360 at the center. Let's subtract these all to the other side. Let's go over to the calc here. All right, so let's go to 360 here. We're going to subtract these angles. We're going to subtract 36. Let's subtract the 95. Let's subtract the 101. And let's subtract the 44. And we're left with an 84 degree angle. So C should be 84. Now again, why I'm coming up with this. If I subtract these over one at a time, that's the inverse operation, and I subtract first, I'll be left with C and I don't have to do anything else. Okay, that's a lot. Okay. But again, thank you for all those who are actively participating each week. I know that's a lot to handle, but again, thank you for all those who are actively doing some of these activities and whatnot. And I know some of you are very, very active on it because I always get emails if the video doesn't look right or maybe it's not on at the exact time that I want it to be. But again, thank you for all that. This Wednesday, next week, all late work and all the redo assignments should be due. I'll kind of send out probably another reminder on Sunday night or Monday morning, whatever that next activity goes out. But next week's our last week. I know that there's emails going out for the school, like the district emails are going out, reminding students, you guys, to remind you of fees that are due and check-in days for textbooks and Chromebooks and all that good stuff. So keep that in mind. Check your emails, and that's really all I have for school updates. But again, take care of yourself, take care of each other. That's the first priority here, and I hope to see you guys real soon.